Hi, welcome to another video on Kubernetes. In this video, we will be talking about Kubernetes architecture. This architecture is common for all cloud providers, such as AWS, Azure, and on-prem installations. Like other clusters, Kubernetes cluster also has master and worker nodes concept. These are deployed in odd numbers to avoid split-brain problem and help in electing the leader. The master node is responsible for managing the Kubernetes cluster. It is also responsible for storing information regarding the different nodes, planning which containers go where and monitoring the nodes and containers on them. It is possible to do all these using a set of components: etcd, Kube Scheduler, Controller Manager, Kube API Server, Cubelet, Kube Proxy, together known as control plane components. Let's take an example of a working airport to understand these control plane components. Just like the air traffic control tower, which is one of the primary components which enables arrival and departure of flights seamless. Similarly, the Kube API server is the primary management components of Kubernetes. It is responsible for orchestrating all operations within the cluster. Kube API server exposes the Kubernetes API, which is used by external users to perform management operations on the cluster, as well as various controllers to monitor the state of the cluster and make necessary changes as required. These APIs are also used by the worker nodes to communicate with the server. Just as the airport holds the information of arriving and departing flights, the cluster holds a highly available key value store known as the etcd component. etcd is a database that stores information in key value format. The airport maintenance team performs various checks before every flight, and if some parts are broken or loose, they are replaced. In Kubernetes, controllers are available to take care of different areas. Node controllers take care of nodes. They are responsible for onboarding new nodes to the cluster, handling situations where nodes become unavailable or get destroyed. The Replication Controller ensures that the desired number of containers are running at all times in your replication rope. Based on flight capacity, the luggage and the number of passengers are decided. A small carrier may have a small number of guests as compared to a large carrier. Similarly, the Kube Scheduler identifies the right node to place a container on, based on the container resource requirements, worker node capacity, or any other policies and constraints, such as taints and tolerations or node affinity rules. Each flight has a pilot, and it listens to the instructions forwarded by the air traffic control tower. Kubernetes also has an agent which runs on each node in a cluster. It is called Cubelet. Cubelet listens for instruction from the Kube API server and deploys and destroys containers on the node as required. The Kube API server periodically fetches the status report from the Cubelet to monitor the status of the nodes and containers. This means the Cubelet manages the container on the nodes. All the application containers and worker nodes need to communicate with each other. For example, the web server running on a container on one node needs to talk to a database container running on another node. This communication between worker nodes is enabled by another component that runs on the worker nodes known as the Kube Proxy service. Kube Proxy service ensures that the necessary rules are in place on the worker nodes to allow the containers running in them to reach each other.